So 810 and drones. Somewhat relevant. 810 is general environmental requirements, general testing. It's not a segment that's really been gotten into too much. 810 is a MIL spec. DO160 is more of a commercial spec. It may be more relevant, but both are relatively similar. 810G is really just a test program guide. Think of it more of an abstract. It covers test, the procedures, the methodology, requirements, applicability. Some things aren't too applicable, and I get to that a little later. The technical guidance for the parameters, there's the appendices in 810 tend to be very in-depth, sometimes too much so. There are the durations of the definitions for the parameters and durations, which in 810G change 1 is tailoring is required, and I'll get to that a little later also. It gives you some basic climactic conditions for where it's expected to be used. It separates it into temperate, hot, cold zones, desert zones, that sort of thing. And some very loose guidance on pass-fail criteria, which I will get to at the very end of this. Slide. And this is just a general list of all the test methods. In between 810G, DO160G, and IEC 668-2, they're all very similar. It covers the same general tests. The parameters in some are different. The intended goals are different, but they can be looked at as very, consider them sisters, really. Thanks. So some tests that are applicable and some that aren't so much, even though you might think so. Altitude is, on the surface, the most useful. It's a thing that flies. The problem is, between regulations and mechanical limitations, your altitude is really limited with your AGL. So you've got a couple mechanical considerations to think about. Lift versus altitude. If you're flying at sea level, your air density is significantly different than, say, if you're flying in Denver. So your drone is not going to perform as well. It might crash. Little experience for that. And another one that a lot of people don't think about is dispersion of heat at altitude. As you go up, your air density decreases. So your means to propagate a change in temperature convectively decreases. You can do it conductively through the chassis, but it's very inefficient. And typically with altitude tests, what we see failing most of the time is due to overheating. You've got heat sinks for fans, but when you go to 20 or 30,000 feet, you don't have much air to blow over the heat sinks to cool things off. Not so much an issue with drones because you're never going to be that high, just because of the limitations between the FAA and just what the propellers can allow you to do. High and low temperatures is also somewhat similar. Beyond very basic envelope parameters of what you've designed, your boards, your batteries, lithium batteries especially, there's not a whole lot of temperature things to worry about. You've got to remember that these are going to be flown in conditions that people are comfortable at. So you're not going to be out flying a drone likely at minus 40 C or 140 degrees. It's just outside the design envelope. So as far as component selection, it plays a part. In general testing, probably not so much, at least as far as the extremes go. One thing that is more likely to be relevant is temperature shock. Think of if you're in a car, say 60 degrees Fahrenheit on a summer day, and it's 105 degrees out. You take your drone out from the trunk of the back seat, and it's outside. You've just done for what these are, a rather large temperature shock. And the same thing goes from, you're outside flying your drone in the winter and you put it in your car that's hot. It can lead to, issues with optics, as well as humidity, control parameters, that sort of thing. Temperature shock is more likely, I think, something to look at for drone testing than just a static temperature. Humidity also plays a part in that. When you're flying, and it's not so big a deal with the altitude you're looking at, but thermocline layers, as you're going up or down, you go through different heat layers, and that also influences humidity. So if you're up high and the drone is cool, and you come down and you're in a warmer, more humid environment, how is it going to affect the optics? The primary driving thing with drones now seems to be to have cameras and video cameras on it. So are your cameras sealed well enough to resist ingress of water for that? Next slide. Sand and dust. Strictly from an 810G standpoint, the way sand and dust is conducted is not applicable to drones. You're looking at putting these in a chamber with a very high air velocity and a very high particulate density. And when you go back to conditions that people are going to be operating these in, that's not too realistic. But you also have to think about these are going to be used outdoors. You're going to be, people fly these in beaches, they fly them over lakes. So not so much from strictly sand and dust, but as a general mechanical ingress protection. You know, do you have a spot where if it crashes in gravel, bits of gravel are going to get into it? If you crash it in sand, how well protected is it against that sort of thing? It's more, sand and dust is not so much a strict guideline for this as an idea to look at your overall test process and design. Immersion rain is also similar. It kind of goes with the test being somewhat applicable, but not strictly. Most people aren't going to dunk these, although it could happen. People do strange things with drones. And you could be flying and flip the controls and dunk it in water. So realistically, is it going to survive that? Probably not. It might. Rain is another one where people are going to be out flying this. It may start raining while they're flying and they have to get it back. How well does it handle rain? Light rain. You're not going to be flying in a thunderstorm or really have an expectation that people are, but it goes back to the sand and dust, just more of an idea of thinking about your general mechanical design and what this is going to handle in the real world. Shock and vibration, more relevant, really. When a lot of these are put in cases, Pelican cases, which are impossible to kill. The contents aren't. Backpacks, that sort of thing. You've got ground transportation, FedEx, UPS shipping things. Shock testing, the same thing shipping. Boxes in FedEx trucks are not well liked. The drivers get them on and off as quickly as possible. So you've got that. You've got transportation in cars. You've got transportation.
Just a question, the MIL standard 810, so someone like a Northrop Grumman or Blackford who build drones, let's say, they have to do that MIL standard. Is it in the manufacturing stage where that test kicks in?
It would be. It's going to be, and really that starts off with when they get the contract. They have design parameters that they have to meet to fulfill a particular contract. So it would be written into that contract that it will meet 810G, or if it's a Euro spec, there's different countries. India, for instance, has kind of an 810G derivative. So they wouldn't need to test to this. As far as military use of small drones like this, I'm not quite sure, but I haven't looked too much into that. And as far as the large UAVs,
The recreational, definitely.
Yeah.
Okay. Yeah. All right. So it could be all the above. Okay.
Right. And then confined environments testing, temperature, vibration, humidity, altitude, combination of all four. This is the most realistic simulation of what happens in the real world. You do not have vibration happening with no temperature influence. If you vibrate something at minus 30°C, or if you vibrate it at 70°C, you're going to see significantly different results. It goes back to the realistic parameters of where these are going to be used, where they're going to be carried, but it's not really out of bounds to consider that, you know, in the shipping configuration, these things are sitting in a UPS truck. It might see 0 degrees Fahrenheit. So you kind of have to take into consideration, you know, how your packaging handles that. If the drone is left in the backpack overnight, you know, the plastic is going to be significantly more brittle in the winter, and you may have warranty issues with things breaking. Excellent. You can play that video.
You just click on it.
I shouldn't be having a bad day. This is seismic testing for a rack assembly, but there is some umbrella here.
How many G's do you think that is, Corey?
G-wise, I don't know. Since it's a seismic, it's very high displacement, but it's low. But it's
Acceleration.
a high acceleration. This is kind of a trick question, though. Did that pass or fail? And with what's on the screen, what we saw, there's not enough context to tell. Testing is not strictly defined as does it work afterwards, did it fall apart. If this was prototyping, it was an unmitigated success. There's a lot of stuff that, just by watching this, completely ignoring accelerometers and data and everything that you get off of the units, things aren't going to work in the real world. You need to change things. Now, if this is an in production thing where you're actually doing complete unit testing, more than likely it failed. Although seismic, it might not, because they didn't come loose. They wouldn't kill anybody. And this gets into the next slide. Sorry, Steve.
We need a new operator.
So as a basic summary, the biggest thing to think about, especially in this sort of thing, is products are used in the real world by real people. You can, it's very easy to design something that you're going to sit on a bench in a lab that never sees anything outside of remotely comfortable conditions for a human. These things go out in the real world. People are going to kick them. They're going to crash them. They're going to fly them in rain. They're going to fly them in the snow. They're going to fly them in the cold. They're going to dunk them in water. So while it might not be a driving parameter to design a drone that can survive all this stuff, because you're probably not going to be able to do it, you have to consider that the envelope and the boundaries that you set as far as testing may be exceeded by people in the real world. And this kind of comes down to your testing goals. Are you doing prototyping to determine possible issues with it, just as a general proof of concept thing? Is this a good idea? Is it a bad idea? Is it going to fall apart? Or are you looking for a more reliability end product or a warranty mitigation thing where, you know, if you have a small failure, it might not be that big a deal compared to your volume of units. If you're selling significant, you know, $50 drones, when you look at the cost of testing, you're not going to do as much just because of the expected market. The standard, especially E10G, dictates tailoring. Change 1 dictates that the test must be tailored. You have to come up with a test procedure that outlines where the units will be used, how they'll be used, who they'll be used by. And that allows you to determine what your test parameters are. It allows you to determine applicability of testing. Some tests might not be relevant depending on who you're selling to. This comes down to test depth. If you're selling very inexpensive hobby-style RC drones, and you look at the cost of a test, a full-blown E10G test can hit $100,000 easily. You look at how many you're going to sell. If it's not expected to be a high-volume thing, you may do just very basic things. General temperature testing, transportation, shock and vibe, maybe humidity to make sure your optics stay okay. But if you're looking at something that's more expensive, like this guy, which some of these go up to $1,500, you may really want to think about doing more testing because you're going to have a better baseline and prototype to come back and fix things before they go out. And tailor the testing to fit properly. Consider your conditions, everything from before, where they're going to be used. If you're selling these in Scandinavia, a guy in Norway is going to have significantly different test environments than somebody who's flying this in, say, Brazil. Look at where they're going to be sold, who they're going to be sold to, and what is relevant there. Pick your temperatures. If you're selling something in Norway, you're not likely going to see something that needs to be tested at 70°C. It's just not realistic. And it comes down to also test sequence considerations. There's 2 driving ways to do that. Do you do the most severe test first, or do you do the least severe first? This also comes back to prototyping, the number of units you have, what you want to get done with the testing. The most severe testing first will more than likely, and this is the most severe as far as the worst parameter. It could be if you have something that's very thermally and humidity stable, but it's very physically frail, you may want to do vibration testing first. That's going to be the most severe. If you have something that's a monolithic block that you can't break by kicking across a football field, you may want to do temperature testing first, as that might have more effect on it. And then you also look at cumulative effects or individual approach. You can test cumulative where all the tests are done to 1 unit or 2 units. You can test multiple in parallel. Or is each test going to be applied to a separate unit? The individual approach tends to be more focused on the prototyping. It allows you to iron out individual problems, issues with temperature, and issues with vibration, that sort of thing. Cumulative testing is better for an end goal thing where you've got your final unit, it's done, it's ready to sell. throw everything at it and see what happens. And the biggest one, and this hits a lot of companies that come in, is determine your pass-fail criteria before you start testing. Like the previous slide showed the video, you need to know what you consider a pass, what you consider a fail. 810G does not tell you what passes or fails. Aside from a very few tests, crash safety, the unit cannot come loose and kill someone, 810, DO160, and 668 are very squishy as far as what constitutes a pass or a fail. Unit must be operating. Determine what your operational criteria are. Is it just turned on? Is it something that has to transmit a lot of things? Is it a mechanical thing that has to be actuated? If it is mechanical, also consider these running test chambers. You might not physically be able to actuate that sort of thing, and that has to be taken into account with deviations during testing. But don't start testing and then decide what passes or fails. This drives a significant amount of out-of-scope testing because something comes in, it fails, although it might not fail because we're not really sure. It might pass, but we've got to check. It sits in the chamber, and this happens to quite a few people. It can definitely cripple test programs because of cost that you have to stop before you finish everything relevant.
This is something you have to negotiate with your customer a lot of times.
Well,
what kind of criteria are they, and
right.
this is why the planning is important.
Right, it can be very end-user driven. If you're selling to the general public, well, you've kind of got a group thing where, okay, what are these guys? If you're selling to a specific military entity, they're more than likely going to have requirement documents that you have to, they're going to have their own pass-fail stuff in there. But a lot of that is end-user driven. So, I think that is it.
Does the FAA recommend or require some subset of these tests in general, or is it kind of the Wild West?
I think it's the Wild Wild West a little bit with that.
Yeah, as far as hard requirements, in order to sell these, I don't think there are any. I think this is more, right now, looking at warranty mitigation and are you selling something on the market that you're going to want to say you sell. If you don't do any testing, you come out with a piece of junk that flops over dead as soon as you take it out of the box, it's kind of pointless.
You certainly need FCC testing because they're all radio controlled.
Yeah, you could have an FCC derivative of DO160 probably, but right now there isn't any hard driver behind that aside from individual companies and who you're selling it to.